Let's move on to objective number 4 for Unit 1. Identify the criteria used for establishing whether an element is an essential plant nutrient. How do we know? This is how we do this. Okay, and this is how scientists have done this. So let me give you a brief background. If you don't know this, you're going to know it now, that plants absorb many inorganic ions, and they actually absorb some organic compounds as well. And they absorb these from the soil solution. So the liquid phase in the soil. There has to be liquid and there has to be contact between the root and that substance or ion within the liquid for the plant to take it up, if it will take it up at all. Absorption by a plant is simply determined by the presence of the ion in solution and certainly not by the plant need. And thus, the presence of an element in a plant is not proof that it's needed. For example, you can find lead, you can find cadmium, you can find gold, you probably can find, well, you can find arsenic and selenium, you can probably find radionuclides within a plant, and they are not essential for plant growth. In fact, if you were to look at plants, take a plant tissue and analyze it, there's at least 60 elements that have been found within plants, but only 17 are essential. And thus, the total nutrient content in a plant certainly may not indicate that the plant is requiring those elements or needing those elements. So how do we know? How do we know that the plant needs 17 and doesn't need the other 43? That equals 60. So the element is involved in a metabolic function within the plant, right? So I can tell you that lead is not involved in a metabolic function. Cadmium is not involved in a metabolic function. Gold is not involved in a metabolic function. But the 17 essential elements necessary for plant growth are involved in metabolic functions. Photosynthesis, for example. The second criteria is that the plant cannot complete its life cycle without the element. If you remove the element, the plant is going to suffer. It's either going to be deficient, or if you can remove the element altogether, such as in a hydroponic system, the plant may not even grow. And the third criteria is that the element performs a function that cannot be substituted for by any other element. So if you were to look at the periodic table here, well, let me take a step back. So you learned hopefully about the periodic table of elements at some point in your life. And you should have learned that these columns, or the elements within these columns, tend to act somewhat similarly to one another. So for example, the first column here, or row, I'm sorry, the first row, all these elements have a +1 charge. All right, so they're all maybe going to act and interact in soils and potentially in plants somewhat similarly. But for example, plants need potassium. They certainly do not need sodium, except for sugar beets. And they're only required in small concentrations. But potassium, in this case for plants, cannot be substituted by sodium, lithium, hydrogen, rubidium, cesium, francium. You can't substitute these other elements for potassium because they do not act the same within a plant in terms of a metabolic function. And so there's only 17 essential nutrients that perform this within plants.